Okay, guys, picking up where we left off yesterday with our complex numbers. I gave you a challenge, so to speak, and asked that you try and figure out this multiplication. 3i times negative 5 plus 2i. How do we multiply that? We need to do what? Distribute. Okay, so we are distributing there, which means I'm going to take that 3i and distribute. And keep in mind, the i's, even though they're not variables, we can kind of treat them like variables, can't we? So, what's 3i times negative 5? Negative 15i plus 3i times 2i. 6i squared. Because I times I would be I squared, yes? Just like if it was x times x, that would be x squared. So I times I is I squared. Thoughts on what else we can do to finish this problem?
Can we square 6i and 15i?
No? Kendra?
I squared equals negative 1. So would we use the 6 times negative 1 to get the x part?
Mm-hmm.
Is it the square root of negative 1 or just negative 1?
Okay, so if you recall yesterday, I itself is the square root of negative 1. So the I has to stay as I. We can't, replace that with anything simpler. However, I squared is equal to just the number negative 1. So anytime you have an I squared in your answer, we can automatically take that to the number 1. Meaning this is still negative 15i plus, but it's 6 times negative 1. So instead of plus 6i squared, 6 times negative 1 is going to make that what? Negative 6. So I instead can rewrite this as negative 15i minus 6. Okay. I really don't remember how specific Math Excel will get about their form. Okay. Technically, when we're talking about multiplying complex numbers or doing anything with complex numbers, we want our answers expressed in the form a plus bi. Now, if I suggest that you express your answer in a plus bi form, what is the one thing I can change about this problem to make it a little bit better form on my answer? The order. Okay? Meaning, negative 6 is the real part. The minus 6 is the real part, so I can put that first. And then the minus 15i is the imaginary part. And so, this best written would read negative 6 minus 15i. Okay? Questions on that? Okay. And here's what I will say is is Math Excel going to be picky about the order you enter your answer? And that's what I don't remember. Okay? I don't know. I feel like I'm not sure that it would recognize negative 15i minus 6 is a different order. But maybe it would. Okay. So i's are allowed in answers. I squareds, not, because they become negative 1s. Okay, let's try B. 4 plus 3i times negative 1 minus 2i. What do we have to do to multiply B? What's that word? Okay, distribute. When we distribute, and there's technically, if you guys just want to say distribute, that's fine, because we're going to distribute the 4 to both pieces and the 3i to both pieces. What's it also called? FOIL. Okay, and distribute is actually officially the more mathematical word if you want to get specific. But also when I say FOIL, I think that triggers something for some people that, oh, okay, yeah, I know how to FOIL. So, okay. First, 4 times negative 1 is negative 4. And then outside, or distribute the 4 again. So 4 times negative 2i is negative 8i. Now I'm going to distribute the 3i, or I'm going to do my insides. 3i times negative 1 minus 3i. And then last, or I'm going to distribute my 3i again. 3i times negative 2i. Negative 6i squared. It is important you remember that I squared. Okay? Now what? Combine like terms. In that negative minus 8i minus 3i will go together. What is minus 8i minus 3i? Minus 11i. The minus 4 I'm just going to carry down for right now. What about minus 6i squared? Yeah. I squared. We don't leave an I squared here. And so this I squared, I'm going to automatically change it to a negative 1. And negative 6 times negative 1 is going to make it a plus 6. So I really have negative 4 minus 11i plus 6. And what do we get when we clean up here?
2 minus 11i.
Okay, 2 minus 11i, because like terms of negative 4 plus 6 is going to be 2 minus 11i. Okay. This is important. We have the idea going forward of what we're doing, because as we work into the division problems down below, we'll need to have a good idea of how to multiply. Okay, what about C? Seven I times 3i? Okay, it's not FOIL, it's not distribute, it's just 7i times 3i. What is 7i times 3i? Seven times 3 is 21. I times I makes it I squared. 21i squared. Do I get to leave my answer like that? No. What do we know about I squared? Negative 1. So now it's really 21 times negative 1, which is negative 21. For the benefit of learning, and today, you'll notice that I keep, every time we see I squared, I write it in as a negative 1, yes? Eventually I'll quit doing that as much. But I feel like right now I have to kind of make sure I put in, plenty of notice there. Or I'm going to have people saying, whoa, where'd the I squared go? But I'll be honest, I see 21i squared, my brain just knows to change it to negative 21. Basically, the I squared, take it off, change the sign, you got it. Okay, in order to keep things moving, and I have way too many examples for what we really need. You guys know what you do on number 4, right? You would have to what? FOIL, or I guess example D is what I really mean. I call it example 4, but we would FOIL there. Okay, I want to go ahead and jump down to problem 4 down here, keep us moving a little bit, to where we talk about division. Now, we say the word division, and I think it was my 6-hour class yesterday that kind of started, oh no, it's going to be division, yuck, fractions, But even though we say division, we're not really doing an actual lot of division, okay? There's a side note right here that's important. To divide complex numbers, the key is we can't have an I in the denominator. Just like you can't leave a radical in the denominator or square root, you can't have an I in the denominator. So to divide complex numbers, you multiply the top and bottom of the fraction by the conjugate of the denominator. Okay? So, for example, if your denominator is 5 plus 2i, then we're going to multiply by 5 minus 2i. And by multiplying by the conjugate, we're going to get the i's to cancel out. Okay, so even though it says to divide the complex number, the key is really to get rid of the denominator, or the I in the denominator. Now, I'm debating which one I want to do first here. Okay, we'll go ahead and do A first. The question asks, what is each quotient? So it's asking, what is the answer to the division problem? 9 plus 12i over 3i. We have an I in the denominator. We said to multiply by the conjugate. Any thoughts of what the conjugate of 3i would be? Negative 3i officially? Because if you think of 3i in terms of a plus bi form, that's going to be 0 plus 3i, correct? So the conjugate of 0 plus 3i would be 0 minus 3i. Does that make sense? So, what we're going to suggest is that we're going to multiply the denominator by negative 3i. If I multiply the denominator by negative 3i, we're going to multiply the numerator by negative 3i. Okay? So this one's going to work out slightly different just because there's only one term in the denominator, but it actually makes it easy, or easier. How do I multiply my numerator? How do I multiply negative 3i times 9 plus 12i? Distribute, because we have one term here, negative 3i, we're going to distribute. It's going to multiply by the 9 and by the 12i. So negative 3i times 9 is negative 27i. Negative 3i times 12i is, there we go, minus 36i squared. Denominator, 3i times negative 3i. No? What's 3 times negative 3? Negative 9. I times I squared. So negative 9i squared. Okay? Now, the key is to do a bunch of cleanup here. What's the one thing we know? Okay, any place you see an I squared, I'm going to replace it with a negative 1. Okay, so both of these I squareds here are going to become negative 1. Excuse me. So that means my numerator, negative 27i, instead of minus 36i squared, if that I squared becomes negative 1, how can I read that? Plus 36. In the denominator, instead of negative 9i squared, if I squared is negative 1, negative 9 times negative 1 becomes positive 9. Okay? Keep going. Don't stop here. Yeah, what do you notice? This 9 in the denominator can divide into both pieces in the top. And since I can divide into both pieces of the top, we want to do that. So I'm going to split this into two fractions. I'm going to think of it as negative 27i divided by 9 plus 36 divided by 9. And you'll always want to split it up because they're always going to want your answer in the form a plus bi. They won't let you leave this as a fraction here. Okay? Now, what do we know about negative 27i divided by 9? Negative 3i plus 36 divided by 9? 4. officially, to make this an official good answer, how should we write negative 3i plus 4?
4 minus 3i.
Yeah, to officially put it in your a plus bi form, positive 4 minus 3i. Because you want your real part first and then your imaginary part. Okay. Questions there? Yes.
Couldn't we have just split it up from the beginning?
Instead of multiplying by the negative 3i? It would not, the 12i over 3i would have been nice. But 9 divided by 3i, you still would have had to work to get that I out of the denominator. Okay? When I say multiply by the conjugate, that gives us one specific method that always works. Okay? Now, could you have gone ahead and split it and just dealt with the 9 over 3i term? Yeah. You could have made that work as well. Okay? Okay, let's try B. Two plus 3i over 1 minus 4i. What do we do to get this in a different form? Multiply by the conjugate. Conjugate of what? The denominator. So my current denominator is 1 minus 4i. So what's the conjugate of 1 minus 4i? One plus 4i. Wasn't sure if that was what I heard or not. Okay, it's just changing the sign in the middle, right? You're changing the sign in front of the imaginary term. If I multiply my denominator by 1 plus 4i, we're multiplying the numerator by 1 plus 4i. How do I have to multiply here? We have to do more than just multiply the like terms. Distributing. We're multiplying a binomial times a binomial, so we're distributing that 2 into everything in the second parenthesis, and we're distributing the 3i to everything in the second parenthesis. Or another way of saying it, we are foiling. 2 times 1 is 2. 2 times 4i is 8i. That's outsides, insides. 3i times 1, 3i. 3i times 4i, 12i squared. Okay? Repeat the process on the denominator. FOIL your denominators. Good news is, since they're conjugates, we'll see something happen with those middle terms. So first, 1 times 1? 1. Outsides, 1 times 4i plus 4i. Insides, minus 4i times 1, minus 4i. And last, minus 4i times positive 4i. Minus 16i squared. Okay, what are some of the pieces you see here? Okay, we can combine like terms on the top. In the 8i plus 3i will be 11i. And what happens when we combine like terms on the bottom? 4i minus 4i will cancel. And when you multiply conjugates, that's what always should happen, is those middle terms cancel. So, and then what's the other thing you can tell me before I start writing this all out? Okay. Those I squareds need to become negative ones. Okay, so my numerator for the moment, I have the 2 out front plus the 11i, and then a plus 12i squared. When we change that I squared to a negative 1, really becomes minus 12. I'll clean that up in a moment. Denominator, we've got a 1. The 4 i's cancel. What about minus 16i squared? It really turns around and becomes plus 16. Okay? Clean up like terms again. Okay, in my denominator, 1 plus 16 is 17. In my numerator, 2 minus 12 is going to be negative 10, and then still plus 11i. Okay. Good equivalent, final answer. But if I had to guess, MathXL will complain about this answer. This is not what MathXL would call an A plus BI form. This is not in complex form because it's one big fraction. It's A plus BI jammed together. So how do I write this so it's A plus BI? So it's real plus imaginary.
Could you add this 17 to the 10? Or subtract it?
Well, what's this denominator do? This denominator goes with both pieces. Kind of like over here when we looked at this one, and I'm pointing off the screen, this 9 went under the 27i and the 36. Same thing's going to happen over here. Even though it can't divide this time, we still want to separate it out in that we're going to have negative 10 17ths plus, and then we're going to say 11 17ths I. Now, I just wrote my answer like such. Negative 10 17ths plus 11 17ths I. You'll notice I put my I after the fraction. Okay? You have two options for your I. It can either go after your fraction, like right beside the fraction, or it can go in the numerator with the 11. Where it cannot go is in the denominator with the 17. So it's either the numerator or it's just right after it. Okay? Questions on that one? Okay. Now, sorry, I'm just trying to look at time. I've done minimal examples. I haven't even, I feel like I need to do 2 in that section. I need to do a couple in the previous section. I'm not going to make it through notes today. Thank you, 2-hour delay. You are so nice. Let's go ahead. I was debating if I wanted to do one more of these. Do you guys feel like you want one more of these? It's all variations of what you've seen. I mean, I don't think there's anything too different if that, Okay. I'll look and I'll double check that nothing too different happens in either of those, and we can always go back to it tomorrow. Let's real quick get you guys started into a solving of an equation. Okay, we'll just do A here, and that's all we'll have time for. 2x squared plus 32 equals 0. We solved equations using square roots several lessons back. It was the lesson we completed the squaring. Don't let that scare you, though. This was the easy part. Do you remember how to do this? When it's just an x squared, when there's just an x squared, what do? I'm not going to divide them yet. Can we just get the x squared term by itself? So let's subtract the 32 over. This will come back to you. You guys liked these. These were easy. You just don't remember them right now. Does that make sense? So if I keep the 2x squared, subtract the 32 over, so then it's 2x squared equals negative 32. How do you work to get that x squared by itself? Divide by 2. If I divide by 2, x squared equals negative 16. What's our normal rule here?
Take the square root.
Take the square root, right? When it's x squared equals something, you take the square root. If you take the square root of the left, take the square root of the right. What's the square root of x squared? X. What's the square root of negative 16?
16.
Okay, so think of it as square root of negative 1 times square root of 16. What's the square root of negative 1? I. What's the square root of 16? 4. So what's the square root of negative 16? In an equation setting? 4i and negative 4i. Plus or minus 4i. Because when we take the square root in an equation setting, we have to account for the positive and the negative roots. Does that ring a bell? Okay. So remember, we're back to these equations have two solutions. Okay, questions on this one? Because that's going to have to be my stopping point. Okay, we will practice with a couple other B and C there. We'll practice with some quadratic formula tomorrow. Maybe look at a couple of, probably not all three of those, but a couple of those. And then I will have to remember right now it's showing as lesson 4.8 being due tomorrow. I will have to go in and change that. Okay? And then I will probably push 4.9 off a day, but I'm going to have to decide how I want to readjust my lesson plans. Okay? So that's where I'm at right now.